Hello, everybody.
Hi, everyone.
This is Duffie. I'm co-hosting. This is the first TGIK, as far as I know, ever that has been co-hosted, and it's myself and Kris.
Yay! It feels good to be back. There was a lot of nostalgia when we were getting ready and we were doing the before TGIK YouTube things together.
Yep.
But yeah, we're hanging out live at the Cystic Studios.
Indeed, taking the show on the road, as it were.
Yeah.
We're basically. It's funny that the two offices are pretty close. I work near 2nd and Bryant, and Kris's office is near 2nd and Mission, I guess it is.
Yeah.
And so it's like a close walk by. So yeah, great to see you all. Let's see who's with us today.
Yay, this is my favorite part, and I'm really excited because I think there's a lot of my new fellow employees here.
Yeah. We got Sean Smith. Hello, Sean Smith. We have Marky Jackson.
Hey, Marky.
Vincent Valencia. We have, of course, Kris. We have Anti-Tree. Hey. And Sundeep Lambda. We see you out there.
Pop!
And Mr. Pop is with us, which is awesome. We have Lamati, one of my other persistent followers of this show. He's like such a bright light in this whole experience.
He's been around since before I even got involved. So
yeah,
he's more senior than I am at TGIK.
We appreciate you, Lamati. We're glad you're here with us. We got Rory, one of the people who works on Kubernetes security, and up with other really interesting stuff. I got to meet and hang with Rory at Black Hat this year. That was really awesome.
Nice.
Got Leonardo.
So Leonardo is one of the Falco engineers.
Right on, both of you. And then we have Antoine from Paris. We got my buddy Tim Carr. Who
Timmy.
We have Sean Smith. I think we already said hello. And then we have Joy, Philip, Matt from Madison, Wisconsin, and Sudeep from India. Marcin from Krakow, and Dennis from Germany, Tolgan from Turkey, Aaron from Southern California.
Yo, from SoCal.
Yeah. That's going to get, so we're about to blow up SoCal here in a couple months. We're going to be at KubeCon. We're going to take San Diego over.
I was in LA for a day last weekend, and then I was in Palm Springs, and I was hanging out with my LA friends, and it was the most SoCal. I had such a great time. It was extra.
Yeah. Nice, and you get climbing in while you were down there?
No, we just went to the pool.
Yeah. I mean, that's definitely a good thing to do. I used to like tripping around in the desert out there. It's a beautiful place.
Yeah.
So we have Bogdan from Bucharest and Jameson from Atlanta. We have Adnan, who I actually work with. He works on the same floor as I do, right here just up the street at the VMware office.
Oh, cool.
He came over as part of the Bitnami acquisition. So
nice.
Very good to see you here. We got Saeed from London. We got Casey from Hague. And Ari's man from Raj. Are you saying that your name is Raj, or are you saying you're from Raj? I don't know. But anyway, good to see you.
Yeah.
Welcome. Raj from SF. Aha!
Raj from SF.
That's the mystery. All right. Well, welcome, Raj. So let's flip over to our different scene here. Give me just second to get this figured out.
Oh, the ambient noise sounds like you're in a data center. I'm going to close our windows while you get set up.
Yep. Is it the data center because it's reflective, or is it the data center? You can hear that. I think that window might be older than me. Pretty sure it is, actually. Yeah.
Yeah.
Maybe both of us put together. All right. So our notes this week are going to be held at tgik.io/notes, and if you would like to help us take notes, you're very welcome to do so. But since we're here and we're in this part of the show, let's talk about what has happened this week.
I'm definitely going to take a lot of notes. That's really going to happen.
But yeah, so it's here, tgik.io/notes, and you can hit it. So what were some of the things that happened this week? There was a couple articles that actually Joe pushed in my direction. One of them is the Tilt blog. Tilt is an interesting piece of software. And they talk about basically why developing in Kubernetes is tough, and it's an interesting article. They talk about a lot of the pain points that people have in trying to figure out how to develop and iterate on software, like when you're trying to deploy it into a distributed system like Kubernetes.
Yeah, I mean, it was just yesterday when we were trying to get set up for the show, and we tried 4 or 5 different ways of setting up a Kubernetes cluster that would work for us. And finally, you looked at me and were like, "All right, let's try KubeCorn and see what happens."
Yeah. It turned out, yeah, exactly. And it was basically because part of the show today, we're going to show off dynamic audit within Kubernetes and how that ties into things like Falco, and we're like, okay, but to do dynamic audit, we need to have access to the API server to enable that flag, and we're like, okay, but we also need like a Linux kernel per node, so we can't do kind, which totally my normal MO.
Right, and we needed like a specific version of the Linux kernel, and we needed a kernel module that we wanted to load, and there was just a lot of requirements, and it turns out it was actually really hard to find a Kubernetes cluster that was going to work for us. But we found one, and we're going to demo it in just a few minutes.
Solve the problem. So yeah, I mean, these guys talk about myriad development environments, and they talk about different permissions in RBAC, they talk about network debugging. Oh, and they actually give us a shout out to Octant. Octant was a...
What's Octant?
Octant is a product that we actually just announced, I think it was 2 weeks ago, and it basically what is neat about Octant is it represents a dashboard that you can start locally on your machine.
Yeah.
And Octant has a picker on the up right-hand corner, so if you have multiple clusters against the same kube config, you can just bounce back and forth between them in the same UI, consistent experience, and like understand things.
Oh, cool.
And one of the things they highlight is actually one of the features of Octant that Brian was talking about in his session last week, which was this resource viewer here, which gives you the ability to understand all of the resources that are related to any resource within Kubernetes. So you can pick up the pod, and we'll tell you about the replica set, and the deployment, and the service, and all the other stuff, and you can kind of see if it's wired correctly.
Oh, cool.
So pretty neat stuff. KubeSpy, another really interesting one. Yeah, so good article, definitely worth checking out. It's in the notes on the link. Another one that Joe gave me was Pivotal KPAC. So first I would like to say, as a VMware employee, welcome Pivotal. I'm glad to see you're here. I know a bunch of you are located here in the San Francisco Bay Area, and as VMware acquires Pivotal, it will be really exciting to see what we can build together. So what is KPAC? What do you think?
I'm pulling it up now. It says build service resource controllers. You know how much I really appreciate a good first sentence, but it says experimental build service Kubernetes resource controllers. I have no idea what that means.
Either. It looks like maybe it's a tool for building images. It is a tool for building images.
It says create an image resource, and then there's some stats and some YAML.
Yeah. That's kind of neat. So you can point it at a Git URL, and it will produce an image from it. And presumably it will push that image. So another way, I mean, like, definitely one of the problems we have is, like, you know, as more and more people adopt Kubernetes, they need some way of actually, you know, kind of like making use of those resources that they've spent on Kubernetes to build the images that are associated with the applications that they want to deploy into Kubernetes. So how do they do that? This looks like one of the many ways to do that. So like making use of things like image or builda or that sort of stuff. So
if you go, there's a samples directory. There's like some sample YAML in there. That gave me a little bit of a better idea of what's going on here.
Yeah. Take a look. Which one do you want to look at?
The build.yaml.
Build.yaml.
So it looks like you pass in a builder and a repo, and it like does all those things for you.
Nice.
So it's like a remote way of being like, build this from that.
Yep.
Yeah.
Pretty cool. What does builder.yaml say? Like CMB Bionic, perhaps this is actually just like the image where they're going to do the install. I don't know, but maybe we'll explore that.
Is a good one too.
Benchmark data. Maybe we'll explore this in a future episode. It does look pretty interesting. So check that out if that's something that is interesting to you. And that's actually coming. And as I said before, VMware welcoming Pivotal. There's lots of great stuff that we can do together. You're going to hear, actually, this is just one of the many announcements you're going to hear in the next week as we go into VMworld. I wanted to share this link, which I think is pretty awesome. It's like my friend Hart, who I work with on my team, he was actually going to try and throw some shirts together really quickly that said VMworld is a Kubernetes conference. And the reason I think that is true is because, like, if we just filter for all of the events that are happening at VMworld in 2019 this year, and you filter on the word Kubernetes, 143 out of I don't even know how many. Like, let's see,
144.
Right? Search. Out of 1348.
Okay, that's crazy.
That is crazy. So out of 1,348 things that could match, we've got 143 of them that are that have something to do with Kubernetes. It's totally nuts.
Nice. So we're going to be at VMworld this year.
Nice.
Yeah, so if you go back to the notes, there's a link and it has some more information. But we're going to be at booths, it should say 132, and I know we're going to be doing some live demos. So if folks are at VMworld and you want to come say hi to your friends at Sysdig, stop by. We would love to see you. It'll be a party. We'll get you some stickers. It'll be great.
Will you be there?
Possibly.
Possibly.
Not sure yet.
The wild travels of Kris Nova. You know?
Yeah.
But awesome. But I will be there for sure, and I'll have some booth duty as well. And so I am actually also part of an Ask the Experts session at VMworld.
Mm-hmm.
So feel free to catch us up and see what we're doing. One of the things that Joe wanted to show out was that people who are going to attend VMworld definitely check out this session. This was actually put on by a couple of people who came with us from Heptio to VMware, Aaron and Fabio, and they're there to talk about one of the other really exciting announcements. I'm not going to talk about it right now, but it's super exciting, a way to give you to manage self-service access to Kubernetes clusters across all of the clusters, and I think that's going to be exciting to a lot of people. So check that out. That session should be really great. The next thing. All right, moment of silence, people. This is a pour one out for the Rocket project. When I joined CoreOS, something like 3 years ago, I remember Rocket being really a controversial project at the time, but it was really interesting to see what Rocket accomplished, right? In my opinion, I don't think that I think that Rocket was probably one of the more successful software experiments that has existed, because it helped force the definition of OCI. It helped greatly improve not only the way that we think about security with relation to containers, but also kind of drove Docker to adopt a lot of those promises. So although I'm sad to see Rocket go, I'm actually I never contributed code to Rocket, but I'm also as an ex-CoreOS employee really proud of what Rocket was able to accomplish inside of that community.
I never used Rocket.
It was really cool. We used it in Tectonic. I spent a lot of money.
Now that it's retro, I want to use it and fork it and come up with bring it back to life somehow, because that's just the way I am.
Well, if you want an intro, just let me know.
Okay.
Announce, patch your Kubernetes clusters.
Oh yeah, we had some CVEs. If only there was a security tool that could have helped us detect these CVEs that we could run in Kubernetes.
That would be amazing. What's interesting about this CVE though is that I've seen some, I don't know, what's the word, outlandish news, some big headline getters this week talking about this particular set of CVEs because it's about net HTTP. And so they're like, Kubernetes is bad because it has these bugs. And I'm like,
But isn't the bug in Go? It's not even in Kubernetes.
Exactly.
The bug is in the standard library of Go. It's not even in it's not even how we wrote Go. It's just if you wrote Go, you're vulnerable. So every Go program in the world, Terraform, Kubernetes, they're all vulnerable all of a sudden.
Precisely, right? And so it's not just yes, patch your Kubernetes clusters, do it. It's a good idea, but also, take a look at any Go app that you have that's making use of net HTTP and bump that dependency, because it's everybody has it,
Yeah, this means that Cubicorn is totally vulnerable right now.
Probably.
But we don't really serve anything, so I think it's okay.
That's fair enough. Cilium had a big week.
So these guys are cool because they do eBPF also. Sorry to cut you off.
But they do, yeah, I agree. But one of the things that they dropped this week was version 1.6 of Cilium, which means that they no longer require their own etcd cluster.
Cool.
And they also have a complete 100% replacement for kubeproxy. And socket-based load balancing, a lot of other really exciting things, including they're kind of starting to follow the model that I've seen a couple of other CNIs in the space do, where you can use Cilium just to do the network policy part, just handle that kind of the important security pieces, and then use whatever you want to handle the routing and pod connectivity stuff.
Nice.
So really exciting to see that kind of stuff happening.
I love this cartoon because it's it's got eBPF in there, it replaces kubeproxy, and then it talks about how we're no longer messing around with IP tables, and it's a total in-place replacement, and it's just mic drop, because we've only been waiting for that for 2.5, 3 years now.
Yeah. So super exciting there. Let's go back to our chat, see how everybody's doing.
I've been kind of keeping up with it.
All right, cool. So we got Marco. Hello, Marco.
Oh, Ducey joined. He's on an airplane right now.
You're on the airplane, Marco?
Oh, Ducey. Michael Ducey.
Oh, okay. Michael's on the airplane. Oh. Hello, Michael from Middle America. Good to see you. I actually got to hang out with Michael this week. He's a really great guy, focused on kind of the security space in general as it relates to like all number of things, not just Kubernetes or containers. So really great stuff. We have Christian from Frankfurt, Germany. Hello, Michael. We have Marco saying hello. We have Shahar from Atlanta. We have Zolt from Oulu, Finland. It's great to see you all. I'm glad you're here. I wanted to give a shout out to Radu, who's actually written a couple of these articles. This is kind of like my own personal shout out to like kind of the project. I think it's actually a really great project for being able to kind of like introspect and understand how Kubernetes itself works.
Yeah.
But in this session, he's writing how to do end-to-end tests with kind using GitHub Actions.
Oh, cool.
So like if you develop a piece of software like Sysdig, or if you develop a piece of software like or your own operator or your own controller or whatever for Kubernetes, and you want some way to run end-to-end tests for that software, or this is one of the ways that can be accomplished now. So that's pretty exciting. So definitely check out this article if that's something that is interesting to you.
Awesome.
And then I think we have a couple more.
This one's for me.
This is for you.
Okay, so if you're interested in getting involved with anything Sysdig, particularly Falco, which is the project that I'm going to be working closely with, please feel free to join our Slack. I'm hanging out in there. We got Michael Ducey, Marky Jackson, Pop is in there. Of course, Leo and Lorenzo, some really fabulous engineers from Italy. Of course, Duffie strategically cuts me off in the middle of my...
I'm so sorry.
There we go. Well, wait, it looks like we're coming back. What does it say up at the top?
Yeah, we're good.
Okay, cool. All right, so we're back.
That was fun.
Yep, I think Duffie, the power plug I gave Duffie for his laptop wasn't giving him enough voltage.
Sorry.
Anyway, we're back. So yeah, if you want to get involved, we do weekly planning calls and weekly triage calls where we're going to start mapping out what we want to do next in Falco in the direction of the project. So we would love to have you come join, and we would love to see you there.
Yeah, I'm going to bring this page up because it's actually kind of has more information about Falco and like what's happening there. But like, yeah, I think that it's Falco is a project that is under the CNCF Foundation, right? And
we're in sandbox right now, and one of our goals is to get it to move to. We're going to try to get it into incubation later this year. Yeah,
and I've been like pretty impressed with the project itself, but it's great that like y'all are trying to build an open source community around tooling like this. Like this is pretty incredible tooling for like understanding what's kind of happening in this space. So we're going to talk more about like what I think about this project, and also what Kris thinks about it as we move forward.
Yeah.
So let's go back to our notes. We talked about all these things.
And then the very last one is, we kind of already talked about it. Oh, never mind.
Oh.
No, you're cool. Let's get started. Can we get started?
Yes, let's get started.
Okay. So yeah, if you pull up that document you just had pulled up.
I did have it. Where'd it go? There it is. All right, found it.
Yep. I think Leo and Lorenzo wrote this, and I think Leo at least is on the call, but I think this is what we should go through to begin. Okay. But I'm wondering, so yesterday you asked me what was the difference between Falco and Sysdig, and I was wondering if maybe we could demo that first.
Let's do that. Before I would like to set the stage a little bit, like and like talk about like just like what we like have us both kind of characterize the project for what it is, right? Like what I think it's like what I think it is, and what you think of it is, and like that kind of stuff. So let's do that first. You want to start, or you want me to start?
I want you to start because I want to follow up on yours.
So I've been a systems administrator for a long time. I've been doing security stuff, network stuff, and systems for longer than I care to think about. And some of the tools that we had prior to containerization that allowed us to understand when applications were misbehaving are things like Audit D. Mm-hmm. And the rules that we can write around basically restricting the ability to access particular files or to make particular system calls above, which represented like elevated privilege for applications that we did not expect to actually do that stuff, right?
Yeah.
And for me, the exciting thing about Falco and like what it can accomplish, and it's not just Falco, it's also Sysdig, but like what that can accomplish is that I can take that view of the world, and bring it into like into modern time, right? Like I can actually do that with rules and like with the input based on coming from the file systems, not only the file systems in the underlying node, but also inside the containers, and like all of that is like such rich context for defining what normal is and for defining when things are behaving abnormally, so that you're not in a situation where you have like people who've exploited an application and can sit there for months and just slowly exfiltrate data, and people don't even realize, they have no way of knowing that they're there.
Yeah.
Right? And so that's kind of exciting stuff.
So I'm going to borrow a little bit of what our CTO and my boss, Loris, shared with me before I started here when I was still on my fabulous unemployment journey.
Fun employment?
Fun employment, yeah. And I thought he said some really brilliant things that really changed the way I thought about Sysdig and Falco.
Okay.
And to give you a little bit of background on him, is he's one of the original maintainers and creators of Wireshark.
Oh, cool.
Yeah, and so the whole point of Wireshark was, embracing this idea of the almighty network packet as the source of truth. If it's not in the network packet, it's not happening.
Yeah.
Oh, look, and he just said hi. So I'm totally going to steal his. Lois, I'm stealing your definition here. I'm sorry. I'm not sorry. It's a great way of thinking about it. But now that we're running in Kubernetes and in containers, we could have multiple entities talking to each other on the same system, so that's not a viable way of getting all of the story. So what we did at Sysdig is we started to go to the syscall as the source of truth, and we started to audit those and pull those and bubble them up to user land.
Yep.
And then with a separate process up on top of that, we're able to now do really interesting mappings of how we display this information, and then with Falco, that allows us to take action and actually trigger events and warnings from it.
Nice.
So yeah, it's really exciting stuff.
It's a great definition. All right, so we talked about what it is. Let's talk about what we're going to do. So in this example, we're going to explore some of the documentation around bringing up a Kubernetes cluster. We've already done that part. We're going to deploy Falco to that cluster. We're going to enable audit logging on the API server. This was actually a source of some contention last night. We finally got that working. We're going to deploy an audit sync for Falco, and then we're going to play with the configuration of that audit policy, and then we're going to observe Kubernetes audit events in Falco, and that'll be really interesting because I feel like that's going to give us a ton of context around like the running process, and also that running process in relation to the context that Kubernetes can apply for it. So that'll be kind of cool.
Do we want to show folks a quick Sysdig versus Falco demo so they understand the difference between the two?
Yeah.
Okay. And then we could look at, once we understand Sysdig, we can look at Falco, and then we can explain how we map that with the Kubernetes audit data in this example. And
that sounds great.
Cool. Do you want to jump? Yeah. Oh, you're already there. Okay. So this is cool. We're using a program called Teammate. Thanks, Lorenzo, for sharing this idea with us. And it creates a public SSH URL, and all Duffie had to do was SSH into the URL I gave him, and he is now SSH'd into my laptop. So actually running on my Arch Linux laptop here. So I was able to compile both Sysdig and Falco from source today, so we have two very fresh copies, and we're going to look at kind of just real quick the differences between the two and how like the story kind of evolved here. So the first thing we want to look at is if we just run Sysdig by itself with no commands. It's a command line tool. It's written in C++, and you're going to see everything that's going on at the syscall level in my system. And as you can see, it's quite a lot of stuff.
I see Teammate in there.
You saw Teammate in there?
And lots of teammates, which it makes sense because, like, if you think about it, it's like if you've ever done like a Wireshark capture of your connection into a session.
Yeah.
And you're like, oh wow, all of that's me actually. Never mind. Yeah.
So you can see here we've got all kinds of fun meta information. We got the process, its PID, if it's incoming or outbound. We've got the syscall that it's calling. A lot of wonderful meta information about what's happening inside of the kernel. And how we're able to do this is through one of two ways. Either via a kernel module that we load in our system that would then mount some devices. So if we look here, if I go to /dev, and I do a list, you can see over here we've got Sysdig. Where are they? I don't know.
Falco zeros.
Yeah, we have Sysdig and we have Falco devices, one for each of the CPUs on my laptop, and then there's a program on top, the Sysdig CLI program, that opens those up and pulls data out of the kernel, which is pretty rad. Oh, can I clear? Oh, I can clear. Oh, this is cool. I really like this. So that's Sysdig, and I guess really quick with Sysdig. If you do like a dash help, you can see there's a lot of output here. Oh, I can't scroll in teammate.
You probably could do sysdig-help pipe vim dash.
More. Well, really what I was just going to say, it's not even, we don't even really need to see help. There's a command here, or a flag here, -p, and then we have a whole syntaxing library where we can filter through and add different events and different bits of data like the ones we just saw in the output here. And I'm going to be putting together some sessions where we look at concrete use cases of different filters and how we could use those. So that's sysdig. It's a command line tool, and it's used for pulling information out of the kernel. Now Falco, on the other hand, takes those same internal libraries that sysdig uses, and it wraps them in a loop, and we can apply rules using a rule engine on top of it. And what's cool about Falco is, based on those rules, we can take action. We can take arbitrary action. We can alert. We can fire off a process. We can kind of do whatever we want. And to give a quick example, Duffie, do you want to keep this pulled up? And I'm going to run a container. I'm going to do a Docker run IT bash. And so right now I'm in a container, and if you look on Duffie's screen, you can see Falco is able to alert based on a lot of different things from simply me just starting a container on my laptop. And in those cases, if we chose, based on our rules, to take action or shoot off an email or do whatever, we totally could. Now this is where things get exciting. One of the rules that I have running on my laptop is to check if anything happens in the etc directory. So here, I'm going to touch a file called etc/new, and bear in mind I'm running in a container. I'm not on my host system. Etc new. There we go. Error, file below etc open for writing, which means Falco is smart enough to interpret its rules both on my host system as well inside of a container, which is beautiful. And the way we're able to do that is because we take everything from the syscall layer and bubble it up. So it doesn't matter if you're on your host or running a container, Falco still has eyeballs on you.
This represents like a new way, in my mind, it represents the way that systems like this should be looking at containers. Because what's happening here, like you pointed this out, but I want to reiterate it.
Yeah.
I feel like it's good to repeat important things a couple times. What's happening here is like when you create a container, right, and inside of the Linux kernel, that all of that container is, in reality, is basically just a Linux process and a mapping of namespaces associated with that process. And those namespaces could be network, they could be the mount file system, which represents the file system that is going to be exposed inside of that container. It could be a number of those sorts of namespaces associated with that one running process. What's neat about this is that Falco, looking at the syscall level, or even at the eBPF level, is able to parse when inside of that isolated mount namespace a file gets touched, it can pop an error on that, which means that you can write audit rules like I used to be able to do in the world of there being only one namespace for all of these things, and have those rules be evaluated against any namespace inside of that Linux kernel. And that, for me, is like a game changer. I think that's really awesome.
It's a game changer. It doesn't matter if you're running Kubernetes or running a Linux service or how many containers you're running. We now can audit everything effectively like it's just a regular old Linux process.
Yeah.
Yeah, it's really, really rad.
Really
so that's kind of Falco in a nutshell. And so now, because we know that we can take all of the syscall information, regardless of if it's in the container or not, let's run this thing on Kubernetes and see what we can do.
Mm-hmm. All right, so there, I'm going to flip you. So this is the box I have set up. So this is our cluster, and then let's just do kubectl get nodes. We can see our cluster as it's configured. We have one master and 3 workers.
We're running Kubernetes 1.13 in AWS.
And we also have a recent kernel. We have kernel that's like 4.9 running. And this is important because part of the exploration that we want to do today is like how do you actually gather all this information, this event-based information without a kernel module, like how can you do that with just eBPF? And so we'll be exploring that a little bit today too.
So to clarify what Duffie was just saying, we have 2 avenues in which we're able to pull syscall information out of your kernel. One is via the kernel module, and the other is using eBPF. And there's pros and cons to each approach, and depending on your implementation, one or the other might make more sense. And if folks have questions, feel free to ask them, and we'll do our best to answer them.
Yeah. So right now I'm in my local checkout of get remote -v. So So I have checked out Falco Security Falco, and to answer Lamani's question, that it can use DKMS to actually make sure that it is able to compile the kernel module that will match the kernel that you're in. And they do this in a couple of interesting ways. Like if you're going to deploy Falco as a daemon set, the kernel module is basically compiled on every one of those instances, one of the pods of that daemon set, right? They have that mechanism in which, so if you didn't have like homogeneous kernels across the set, it would be able to use DKMS to compile the kernel necessary for the kernel that you were seeing on that particular pod. Or they also have a way, like if you have like a consistent kernel set and you wanted to like provide like a way to just fetch that kernel module, you could, like using curl or some mechanism like that, you could do it that way.
We can actually show them really quick. It's in the pod logs. Do you want me to show them, Maddie?
I want to. Yes. Integrations. Okay.
You can just pull the pods and do a logs on them.
Yeah. But first I'm going to show this part because I think it's actually kind of interesting. Case with RBAC.
Yep. So Duffie is in the Falco security Falco GitHub repo right now.
So this is the daemon set. This is what we were talking about before, right? So this is actually pulling the image. It's going to have a privilege context, and I bet we could tighten that down, but that's what's there today. And then it's going to have a way to understand what's happening from the container D socket. It's mounting in a service account token.
I think that's why we need privileged.
To do the container D socket?
Yeah.
You could be group bound though.
Okay.
But yeah, there's lots of stuff happening here. It's mounting in the host's libmodules directory so that the module that it creates can be persistent. And that's the configuration of the daemon set. Like it's mounting in a bunch of stuff, pretty high privilege, pretty, like you'd have to be really diligent when you're looking at this stuff to understand like what sort of stuff is kind of being given up from the underlying host. But this is a very highly privileged container, and so that's going to be interesting.
It's interesting because whenever you run Falco in Kubernetes, Falco alerts on Falco.
All right. I mean, I was going to say it's kind of like doing
it totally it's like we detected you're running a privileged container. Oh, that container is this process.
Yeah. So I guess we've already deployed this get pods, and let's take a look at the log of this pod. Get all the logs. Oh, it's doing stuff. I'm going to reboot. I'm going to restart it.
Okay, cool.
Delete pod.
Oh, I didn't know you could do that.
Come on, I did not just tell it. I did not just teach you.
Yeah, no, that's the first time I've ever
a
seen
shell trick. Okay, all right, that's cool. I feel good about that. Yeah.
Wow. I still have Control L on my side though.
Fair enough.
Okay, yeah, scroll to the top. You can see where it loads the kernel module with DKMS. Sorry, I'm getting excited.
All right. Yeah. So in this case, it's saying kernel preparation unnecessary because it already found a module that was related to it.
Yeah.
You can see that it's using a DKMS install. Do you want to talk through this part?
No, go for it. You're doing great.
Okay.
You're doing better than I am.
And then it's basically like building it, build complete. It's doing a sanity check for that kernel module, and it's loading that one in. And this is what I mean by like understanding that it's looking at the kernel that is related to this pod. If each node represented its own Linux kernel because I just was doing a rolling update and I hadn't gotten through them all yet or whatever, then it would be compiling this for each of the nodes individually, right? And so just
can I show this on the back end of the node?
Yeah, on this one?
Yeah, just hopping right there. So I am here on my local laptop and I am going to do a kgit nodes, what is it, OY? Yeah. Kgit nodes OY, and let's grab,
You don't have the same kernel, but you get the idea.
Yeah. I want a public IP, where are they at? That's a master, so let's do SSH admin at 52.12.74.197. So if you come here, we go into device again, and sure enough, at the top up there, you can see we have our Falco devices, and if we do a list mod, and we'll just pipe to grep For Falco, you can see that the Falco probe is automatically loaded with DKMS. So the daemon set actually goes and will install everything you need for you on your underlying node in Kubernetes, so that you don't have to worry about configuring nodes or anything like that. You just have to make sure that your node meets the criteria for us to be able to install the kernel module or eBPF program if you're going the eBPF route, which is very easy to enable. It's in that daemon set that you just had pulled up.
Yeah, one thing that, but in the previous example that you showed us, we saw that we had Falco devices and we also had Sysdig devices.
Correct. So that's because I have both Falco and Sysdig on my laptop here. So they both use the same library, so the probes are pretty similar. In fact, there's a good chance they're almost identical, but they have different names, and the different programs expect different devices. So you would actually have two different kernel modules loaded, one for Falco and one for Sysdig.
Got it.
Yep.
Okay. Cool. All right. So we showed how that works. Let's talk about what it can do. So at the moment, we're using the kernel module mechanism. So let's play with what it can do. So let's go back to our docs.
So this is the part I haven't done yet. So this is where we're going to get into
Yeah. So in doing a little setup, I did actually deploy the API server in a way that can enable audit logging, and a way that you can validate that that's true. Oh, 1 second. There we go. So I'm back on the cluster. If I do kubectl get API resources, grep audit. That audit syncs is actually defined here, means that I've got the API server configured in a way that will allow me to see it. So that's good. Now, before I go on, I want to answer some other questions. I think there was another question in here that I wanted to talk about real quick.
I think it was Labani's question about kernel modules?
It was actually Rafal's question. So Rafal's question about can gvisor compare to Falco? I think, in my opinion...
Nothing compares to Falco.
All right, fair enough. So gvisor is a way of solving a different problem that Falco solves entirely, right? If you're saying, can Falco introspect gvisor running or containers running inside of gvisor? That's a very interesting question, and I don't think it would be able to right off, because gvisor represents a separate Linux kernel or a separate a separate interface for all of the system calls that are happening from within a container. And because of that mapping, I'm not sure that it would expose it in a way that Falco could pick it up.
If it's going through the host kernel where the kernel module is installed, it's ultimately going to end up in the standardized form if we're going to be communicating with hardware.
Yeah, that's true actually.
Yeah.
So maybe it would surface. That would be a really interesting test.
It would be.
All right.
Maybe we could do another TGIK.
Yeah, that's a neat one. Because at the end of the day, if it's still the same. If it's still bubbling up those system calls to a shared Linux kernel, then that's something we can expose. But if we're running that Linux kernel as a process underneath the Linux kernel, a la virtualization, I'm not sure that they ever translate. Like the guest kernel would never try to make use of, in most cases, it would not try to make use of resources that are known by the parent kernel.
Right. So it wouldn't work if we were running virtual machines because they run their own hypervisor, right? But because containers use the host system's kernel, that's how we're able to get this level of inspection.
Exactly.
Yeah.
So it's a really interesting question.
A really easy test for that. So Sysdig, the Sysdig command line tool that I showed earlier, is in all of the Linux repos. You can just pacman and install Sysdig. And so Sysdig is probably even a better tool for just to go and see what you can get out of gvisor. It might be really easy just to hop on a node and just go see what you can see with Sysdig.
True. Also wanted to say hello to Dims, who's with me at VMware, which is awesome. I'm super excited to have
him be working with us. Wait, Dims is at VMware?
Yeah.
I thought he was at Google.
He was.
Oh.
I think you were.
Okay.
But, yeah, he's with us now.
Oh, that's exciting.
We have Lamani. If you use a kernel module, what happens when you upgrade them? We already answered that question. Yeah.
I think we're all caught up.
And let's move on. All right. So, documentation. So we had the audit policy available to us. The next thing we wanted to be able to do is actually deploy
Let me see what
So
we
this
got.
is actually what I wrote, or what I did last night, was basically enable this model. So in theory, there should already be a webhook config configured. So what if we do kubectl logs -f Falco example? What does this do?
I mean, we should already have auditing enabled. We just have to deploy audit sync objects.
Yeah, but I don't see where that happens.
Down below.
Define your audit policy and webhook configuration. Kubectl audit log configuration we use creates the rules and creates audit rules config. Webhook config YAML in a templated. Oh, I see. So this has already been.
That's for 1.11.
Oh, sorry.
Scroll down to 113, and then keep scrolling.
That's
Deploy
right.
sync objects. That's what we want.
That's what I'm looking for. Okay. So we have the audit sync API object. Now we need to actually deploy it.
We do have an audit sync object?
No, we haven't deployed it yet, but we have that API available to us.
Got
So
it.
now we're going to populate that API. Run the following to fill the template with the cluster IP address you created with the Falco service above. Although services like Falco service default service cluster local cannot be resolved from the Kube API server container within blah blah cluster IPs associated with services are routable. Okay, that makes sense. So let's go ahead and run this. What it's going to do is actually just going to create an audit sync YAML that we can then deploy. It's not deploying it for us. It's
Okay,
just
cool.
putting it together. Dang it, I keep doing that. 1 second.
How do you feel about these bash one-liners? I feel like there's like a delicate art to having like a good one-liner that is actually an effective copy-paste.
Yeah, I think that's probably true. Actually, there's a great question for you. Lamani says,
What does Lamani say?
overhead association. What is the overhead associated with running the kernel module on a syscall heavy system?
I mean, they're both obviously going to introduce some overhead. To be completely honest, I have not asked that question yet, but I have a feeling there are folks in chat who can probably tell you a little bit more about the performance of both eBPF versus the kernel module.
Okay.
I would imagine the eBPF program is going to be lighter weight and slightly quicker. That would be my gut, but it might be interesting to do some load testing just to see. We might be able to even do that today. Just deploy like 1,000 pods and see what happens and time it.
That'd be kind of interesting. All right, so here's my case audit config. There's the audit policy YAML or audit sync in. There's that file that we're referencing in the docs.
Oh, and Nick had an answer for Lamani. He says, Lamani, the overhead pre-eBPF was already really low. The convenience of having to add the kernel module was probably more of an issue. Yeah?
Because what you're looking for is just like to get, it's like a stream, right? You're getting an event stream.
Yeah.
So you're not really doing a lot of hard work to parse or modify that event. You're just taking it as a fire hose. And so like what the kernel module doing, and probably what the eBPF binaries are doing, is basically just wiring up that fire hose and getting it out of the way. Right?
Yeah.
Like
eBPF works as a filter, and you're able to pull information out that way. One of the phrases that somebody had written down on a blog somewhere I read a couple of months ago was eBPF is to the Linux kernel as JavaScript is to HTML.
Oh, that makes my brain hurt.
Yeah?
I don't think I want to hear that.
Okay.
I'm like, all right.
Sorry, Duffie.
Okay, but it makes sense. It makes sense. All right, so here we go. So this is actually the generated audit sync object that we're going to submit to our kernel or to our to our cluster.
To our API server. Yeah, I want to see. So it says throttle. What is QPS? Queries per second. And then we have a burst of 15, and then you just pass in your API server URL.
Yeah.
Is that says client config? I think that needs to be the URL of Falco.
Yeah. So if I do kubectl, if I understand it correctly, well, let's just look at the command real quick. So what this is doing is pulling service name Falco service. It's using JSON paths to filter the result into spec cluster IP, and then they're using nstubs, which is kind of like a fancy set, really, to take the template file audit sync YAML in and produce the resulting file audit sync YAML out.
Can we look at the service? I did want to make sure it's mapped to all three of the Falco pods.
Yes.
Sorry to make you type things.
Get svc dash SVC, Falco service. Falco service. So that's our endpoint, and then let's look at the endpoints for the same. Kubectl get endpoints.
So Kubernetes trivia, every time you create a service, you also create an endpoint, and the endpoint is actually what does the dirty work. The service is just kind of a wrapper and an abstraction on top of it.
Mm-hmm. And so if we did kubectl describe service, for example, we'd be able to see the output of both.
Yeah.
SVC Falco service.
So what just happened is we're routing the Kubernetes API server to a service that then proxies to all three of those.
Yeah. So that's cool, because that means, that'll actually be pretty interesting. So that represents kind of a distributed systems problem in a way, right? Because like what we're doing is we're going to send the output from the API server's audit logs, and there could be multiple API servers.
Right.
And we're going to take the output of that and send it to one of the healthy endpoints in this list.
Right.
And presumably the rule set would be common across the set.
Right.
So any alert that it detects, it should be any one of them should be able to take action on.
Right. So if they were all configured to take the same action,
yeah,
you've effectively you've distributed your problems.
Yeah, in a number of interesting ways. So that's
so
cool.
One of the ideas we've been playing with here at on the Falco team, we've been talking about it a little bit. I was talking about it with the engineers Leo and Lorenzo and Mark Stem, is playing with this idea of having a gRPC interface for an output for Falco. Mm-hmm. So that in this example, if we wanted to take one of those pods and wire it up to some arbitrary service or to some arbitrary program, we totally could, and we would still be in that same situation of it could be executed on any one of the three Falco instances, but we could point all of those to the same place and kind of glue everything back together again.
That's true.
So yeah, if folks have ideas like that or want to get involved with Falco, you know where to go.
It's an interesting problem because, like, if you think about it, this is like, I spent a good amount of time recently talking about like event-driven versus level set architecture, right? So like Kubernetes generally is level set. It means that you have a declarative, you have a desired state. Kubernetes is responsible for understanding that desired state and the observed state and converging.
Yeah.
But this system is an event-triggered system in which we have an event stream, right? So if an alert comes through and somebody is listening, and that event is able to be subjected to something that can actually take action on that event, then that action gets taken place. But if you lose an event, if that event, like for example, in the setting of the audit log, we just have saturated the queries per second or the burst, that some of those events won't make it through to any of the endpoints. And that means that we'd have to wait for the next event to be able to trigger it. And so I think it's really interesting when you think about it from the perspective of like all of this data that Sysdig is gathering and all of this data that the audit policy from the API servers is gathering. Like, almost by definition, you're going to be missing some continuity between a lot of those things.
Yeah, totally. Okay.
And so,
let's start it. I want to see what happens.
Noodling on stuff. Sorry, my brain is like full of
This is what it's been like hanging out with Duffie all day today, getting ready for TGI. We've just been in here just nerding out and brainstorming about cool things that might be fun to do.
Policy. Where is it at? It's audit sync YAML. All right, so I'm going to go ahead and apply this to my cluster. Boop. And we see that now. So now if I do kubectl get audit syncs.
I think you can just do AS.
I can see the audit sync that was created. What happened? I've never tried to do a describe of this because this is the first dynamic audit configuration I've ever tried to play with. Describe, audit sync.
I think my brother is responsible for designing a lot of this API objects, so we're going to make sure to give him a hard time.
So I don't see any events, but I do see that it was created. I see a resource version associated with it, and it's saying that it's looking for the stages of response complete and response started.
Yeah.
This is all in the language of, you know what I should do real quick before we move on. If you're curious about dynamic policy, dynamic audit,
it's in the auditing section.
Yeah.
It's just at the bottom.
So dynamic backend, this is what we're configuring here, right? We've already enabled dynamic auditing. We set it to true. We've set our runtime config for this cluster to do that. And we also turned on audit dynamic configuration. And what's crazy about that tool is it allows you to write audit policy on some subset of the resulting audit events from the API server. So instead of actually, instead of just looking at like all of the events in a static way coming from the API server, maybe I want to just trace those events that are related to my application in this namespace. Or maybe I want like to look at these events as they relate to a specific user, right? This lets me dynamically create a policy that would allow me just to look at some subset of information and reduce the amount of context that I end up getting. And that's pretty great.
So we're going to show off Leo's PR really quick. There's a section in here on auditing that pertains to Falco only.
In here?
Yeah, so describe for Falco.
Control F. Falco. Oh, there we go.
Yep.
What's next? Auditing with Falco.
And then so look, we're on the official, Falco is on the official Kubernetes documentation site. Thanks to Leo. Good job, Leo.
Right on, and it's in there. Yeah.
Yeah.
So this is a lot of what we're talking about. Like, so there's some examples of like rules that you can write. Any suspicious, unauthorized, or anonymous user. You can do image-based scanning, like understand whether the pod has actually got an image that you don't know about or the one that's disallowed. And this is interesting because one of the things about this that a lot of people right now are like looking into like how they can further enhance the security of runtime inside of Kubernetes. And some people are making use of tools that try to introspect the running container at runtime and like understand what's happening with it, which is kind of similar to what Falco's doing. But this one is a neat audit rule because we can look at the audit log and understand if a pod were to make use of a container that was not known or didn't make it through admission control, like maybe it was a static pod or something like that. So that'd be kind of a cool example. Tons of these, yeah, tons of things that we could do.
That's awesome. So one of the things that we have also been talking about here on the Falco team is using dynamic audit as with the Falco operator. So in the Falco organization, we have a Falco operator that will get the daemon set up and running for you. We were thinking it might be exciting to configure dynamic audits and start to turn on like an opinionated audit policy and just wire Falco up to that just out of the box using the operator.
Yeah.
Yeah.
It'd be really neat.
Yeah.
So we got this wired up. We have our audit sync in place. We talked about what dynamic audit is. Let's go ahead and do this observe Kubernetes audit events at Falco. Presumably, this is just going to look at the events as they are parsed by one of these pods, but let's take a look.
And I can do malicious things in the cluster while you do that.
Maybe we should reduce our deployment to 1. That way we can actually catch that event. Because right now, right, it could go to any of the 3.
Yeah. Do you want
or I could look at all the
I can
logs.
do it. I don't need to deploy it.
All right. So here is the...
You can do logs based on labels.
That's right. I was just thinking that same thing. So kubectl logs -f. In fact...
I think that's what this is doing.
But why not just... No, this is actually just grabbing
I think
the first in the stack. But you could just do it this way. To your point. Like, you don't need to...
App is equal to Falco. Yeah.
Greatly simplify.
I don't think we need the -f. Yeah. And then F at the end.
Oh, maybe it's because I'm on an old version of kubectl, but in a new version of kubectl, you can actually follow and do what label select.
Let me try on my end.
Actually, if I just jump back to my laptop, I should be able to do it. Kubectl get pods, kubectl get pods, show labels, kubectl log -l app.
Yeah, it's working for me. App equals Falco. And then -f.
Sweet.
There we go.
All right, so what do we got from the logs here? We have morning K8's operation performed by user not allowed list of users. APIs, auto scaling, B1 beta 1, timeout 32 seconds.
Okay, can I do malicious things now?
Yeah, go for it.
Let me pull up my gist. I have this really good example. I can share it with you afterwards. It's private right now, but it's basically doing what you were doing with privilege escalation in containers. Mm-hmm. So let me deploy this. I call it the scary pod.
Scary pod.
Yeah. So Emacs, we'll do scary.yaml.
Oh, let me flip over to that screen so people can see typing. Look, there's a scary pod.
Yep. So K apply -f scary.yaml, and then pull up your logs, the Falco logs, really quick. All right. 1, 2, 3, go.
Woo! All right.
Woo!
It landed and it did stuff. What is it doing? It's touching like.
So it's a privileged pod, and it mounts the root file system, and then it roots into it and starts messing around and touching files. And the host, like through the container, it roots into the host root file system, and then it starts like touching files in Etsy and like doing stuff in hidden directory SSH and like all kinds of goofy, scary things.
Yeah.
Yeah.
What's weird is that it's populating like K8's pod equals NA, not available. K8's namespace, not available. So when
it's probably was still being deployed, maybe? Or is that coming from the audit logs?
Kubectl get pods. So there's a scary pod. And if I do kubectl logs, I grep -I scary. Okay, so I do see. Actually, this is just somebody trying to do a get and somebody doing a create of that pod. But I don't see like the alerts related to that pod. I just see those alerts related to the container.
So let's look at the Falco YAML really quick. It's in the config map. That's another thing we should tell folks. All of Falco's configuration lives in a config map, and you can go in there and you can take all kinds of cool action and configure what you want Falco to do and what level you want Falco to log at and all of the different rules that you have. So check the verbosity, make sure that we're set to info.
Okay. Here's an output false, logger.
Log level info?
Yep.
Okay.
Priority debug, buffered output's false. Kicking into a file called, there's no actually output, so we could actually send the output to a file, which would be neat, but we're not. But we are sending it to standard output. And there is a web server apparently. Oh, enabled. So we started a web server. This is our K8's audit endpoint. That's the configuration of that. SSL is not turned on. So this is actually how we're getting data into Falco from the API server, as we already described.
Yeah.
That makes sense. The program output is not enabled. HTTP output is not enabled. Here are the rules. Falco rules. Local YAML. The rules are.
And we have a lot of rules, and these are just all kinds of things that we've discovered, that other people have hit, folks have contributed some of them. We're just building the master collection of rules of things that are important to system administrators.
Makes sense. Renaming of things, moving of things, removing of things, spawn processes, that's a good one. Create symlink. Mucking around with bin directories. Yeah, all these kind of make sense.
Yeah.
SSH binaries.
So the ones that I really like that are easy to demo are starting a privileged container and doing things in protected directories and reading password information.
Yeah.
It looks like we have questions.
So lots of macros. Oh, let's see what the questions are.
Oh, let's see. So Pop says Falco output available in our commercial products is stick secure now. At the moment, there's a third-party project called Falco Sidekick that probably approximates what you are looking for. via Splunk and syslog. This is a question for POP. So these are all sysdig engineers who are talking right now.
Oh.
Leo, and then Mark says in about the gates being missing, I think those were from system call events. They flew by quickly. Make sure you started Falco with -K option so Falco pulls Kate's metadata from the API server. So let's look at the deployment when you get a chance. And let's look at the arguments we're passing for the deployment. It's in the default namespace.
Wait, the deployment or daemon set?
Daemon set, sorry. Yeah. And then scroll down to the args. Yeah, we're passing dash lowercase k and capital K. So that looks good. Let's check Falco again and see what it's doing.
Oh, I'm gonna call you out.
I didn't write the daemon set.
I know, but I can call you out about it.
I'll take full responsibility for it.
All y'all on the.
No, blame me.
All right.
You gotta blame Nova.
All right. I don't want to blame anybody, but So what version is latest?
So actually that's a hash. It just is a coincidence that it happens to be an English word that happens to be latest.
You're killing me. Image pull policy always. That's good. All right. So you want to look at the log for the?
Yeah, I want to look at the logs, and I want to see. I'm going to start doing some stuff, and I want to see what happens in Falco.
What was weird though is that so I think how about we do this? I'm going to go ahead and reduce this. I can't, right? Because the daemon set has to actually match a label set. So never mind. It's a daemon set. It's running all three. We'll look at the logs for the whole set. Kubectl logs -f-l
app equals Falco example.
Falco example. And then
let's just do that.
What I want to see though.
What do you want to see?
I want to be able to. You see where these fields are being not populated? Well, there's actually one. So there's some that are being populated.
Yeah.
Right. So we see a server's account created in kube namespace, server's account kube proxy in a kube system. That's great. Operation performed by user not allowed in the list of users, which is somebody doing a get of all pods. In the Falco example, that's actually ironically us. So that's what you were talking about, seeing an event triggered by Falco.
Oh yeah, I see. Yeah. So can I start doing some stuff and
let's
see if we see
try it again.
Okay. So you want to skip over to my screen, or should I just tell what I'm doing? So let's do.
Right now you're just on the root node, or?
Okay, so here's what I did. So I exec into the scary pod.
Okay.
So I'm now in the scary pod.
Yeah.
And if we look, I have the root file system mounted in temp route, like the root of the host. So let's go back so folks at home can see. Here I am on my laptop. I now exec into a container that's running in Kubernetes on a server in Amazon. And we were able to mount the server's root file system into the container in temp row, because everything has to be in row. And if we go to /temp, I can root into row, and now I've gained full access of the underlying host. And in here, you can see that I'm actually on the host system, which is different than the root system here.
Yeah. Like if you do cat etsy host name?
Cat etsy host name.
And then, well, that's actually so you've also got the network pulled in, right?
Yeah.
Yeah.
So we want to do OS release. So you can see here
is a Fedora container.
Right.
But then if you jump into Mrau.
And then if I true into Mrau, and we do cat etsy OS release.
That's the underlying host.
Right,
okay.
So now I'm on the host file system. So in here, this is where it's cool. If I touch etsy something, and let's exit out of this, and let's do the same thing in a container, touch etsy something.
Yep, there it is.
We should see both in Falco, regardless of where it happens.
And we do. Oh, and it's actually populated. Okay.
This is cool. This is really cool. Because we're getting Kubernetes information as well as malicious user information, all from syscalls. Oh, this is really cool.
Yeah, so this output, this says error file below Etsy, open for writing, user root, command touch, Etsy something, the file that it was touching, the container ID in which it was being created, the image based on that container ID, the namespace that it's in, the pod name that it was, and the container ID again in the default namespace, pod scary. Yeah, really cool. So it's actually giving you like the full-on output, and then here is the result. Again, that's just the result from within the container.
Yeah.
Because the system call still sees it being owned by the container. So that's cool.
So I mean, with this output running in Kubernetes, we would effectively be able to go back and tell the story of what happened in our system.
Yep. Do we have enough context to be able to say who made that, who made the attach, right? So we have an attach here.
But can we pull in network meta information and get like the attaching IP or whatever?
Yeah. Attach. We just see attach. We don't see the actual source IP address of it.
So what we would probably be able to do would be to go into the rule set and start to pull in corresponding syscall information as well at the network level.
Yeah.
Yeah.
Because then you'd have a real story. You'd be able to say like, this user, and actually I think that probably is. Well, we can't even see. So I think he must be coming in as admin. Yeah, there it is. User root. That might be the user that's making the call.
When I exec into the container, I exec in as root.
So, but we still don't know who you are. We don't know. That's interesting.
Pull requests are accepted, Duffie.
Well, I mean, yeah, I would hope so. It's an open source project.
Yeah. I love watching you hack using Falco. This has been my life for the past week.
So I was trying to catch everything from that timestamp and see if there's anything more useful.
Yeah, so notice a shell is spawned in a container with attached terminal user root. Warning, case operation, we don't care about. Can we minus V warning case operation?
Which one? This one?
Yeah. Just the string case capital operation. Yeah, that string. Anything in there. Like to grab minus V. No, I don't want to see that.
Oh, you want to see not? You want to see not
everything
that?
but that. So do a minus V in front of it, and then do whatever else you're grabbing for after that. For that timestamp.
Begins with 21. What happened to my output?
What just happened?
Right?
Get rid of the graph. There it is.
Still got output.
Are all of those? Do all those match the string now?
Oh, you know what it is? It's probably because I know what it is. Sorry, I'm being silly. Boop, boop. All right.
Now we're still following. Yeah. It wouldn't be TGIK. Look at YAML and forget to.
We were doing a follow, right? And so anything in the follow would only be related to like what was happening there.
Yeah.
But I wanted to see all of the outputs, so I need to aggregate all of the logs and then do a grep on the resulting logs. You want to do that touch again?
Yeah. Which one?
2.
Oh, you can do it.
Yeah.
Because of our sweet teammate session.
So there's our error again.
Okay, so error file below Etsy open for writing, touch Etsy's. Oh, it even tells you what file was touched, what command it was. It says the parent that spawned or forked, I should say, the process, which was, of course, bash. The command line, which was bash, and then there's the file again. So we're getting all kinds of information out of this. Container ID, so this is coming from the Docker context. This is the container ID that Docker is running. It tells you the image, the name of the Kubernetes pod, the user, the namespace.
Yeah.
That's cool.
Was it mentioned in the logs earlier of the exec? Yeah, I saw that, but I didn't see. But in the control, let's see, exit.
Oh, so we have a good question.
So I see the exec. Yeah, I see notice attach exec to pod, user admin. Oh, there's our information. So that's the beginning of our story. User admin, exec into pod scary in the default NS with the exec and got a bash shell.
I will still want to know the IP of where that's coming from.
I would too. Yeah, and actually, you know what's interesting is that I know that from the event log, if you have the audit log, like full audit log, then you get more information. Like you can, like the audit log will give you the source IP as it knows it. It'll give you the, if anybody has forwarded on like what the real IP is. It'll give you what service account was used to authenticate or what user was used to authenticate. So there's a bunch more context that we're just not seeing in this output because we're doing a dynamic log, which I think is probably giving us like less context but more specific to what we're like looking for.
Yeah.
But Falco apparently can be deployed using
non-dynamic auditing.
Yeah, examples.
So while you're doing that, there's a few questions I'm going to answer really quick.
All right, go for it.
Okay, so the first one is, I'm just going to read here. There was mention of logs earlier in the exec into the scary pod from user admin. We just looked at that. Adam says, this is super cool. Has Falco engaged with SIG multi-tenancy? Right now we're primarily involved with SIG security, but I know there's been talk of us getting, or at least starting to look around and introduce ourselves to SIG multi-tenancy and SIG auth as well. So I think as folks start to get more involved with Falco, as we start to grow the community, I think getting involved with the various Kubernetes SIGs is going to be critical for us. We're going to be running a bunch of presumably adversarial pods. Looks like Lorenzo joined, and then we had a question, what's the reasoning behind Falco also aggregating Kate's audit events? So that's a great question. The idea here is that in a world where Kubernetes is the new default kernel, I'll say it, although I feel like everybody's saying it right now, where folks are running their applications, being able to get meta information about how your application is being ran while mapping that to the deep system inspection that we get with Sysdig and Falco, we're able to tell that complete story. And that's what Duffie and I were just talking about, with telling the story of what happened based on the events that Falco and Sysdig are able to give us. Nick Perry says, one related issue, there's a Kube API doesn't support proxy protocol, XFF type headers. So if you access the API via a proxy, you only see the proxy IP. Which, if you're clever and you're really doing something malicious, you're probably going through not one, but probably several proxies of different protocols. So Nick Perry says in the audit log. So yeah, it's a limitation, but I think as we start to expand security and as Kubernetes begins to evolve and starts to look at redoing some of the features that we've already built in, I think we're just going to get harder and stronger over time.
Yep, I agree. I mean, just stronger just this last couple of weeks. I mean, like open sourcing the result of a third-party audit of your entire source code as a project. I mean, like that's a bold move. I mean, I was super excited to see that happen, and it's also just great to see like how quickly we've been able to respond to many of the things that were found in that. So, if you need some light reading over the weekend, definitely check that out.
So Bogdan says that they're asking because in these logs it shows much less data than the actual audit event, which I think is what Duffie was just talking about with dynamic auditing versus true auditing. Yeah. And again, bear in mind we are mapping, and in the Falco rules you define what outputs you want. So if we wanted to see something specific, we would be able to go into the config map and change whichever of our Sysdig variables we wanted to pull out of there.
All right.
Yeah?
Yeah. So there's one more thing I'd like to cover. We've already been at this for about, what time is it now?
It's 2:15, so we're an hour and 15 minutes in.
All right, great. So the next thing I want to show is I want to go back to our cluster and I want to unload the daemon set that's running.
Okay.
And I want to reconfigure the daemon set to use BPF instead of the kernel module.
Yay.
And then we could show like the different loading, like before when we showed this, we showed DKMS like compiling the kernel module and doing stuff.
Yeah.
And then I want to be able to see for sure that I'm still able to see those events like crop up the way we saw them before.
Let's do it. I'm all about it. So let's move that daemon set and edit the YAML.
So while I'm doing that, I think what would be cool, if you want to talk about what you think about eBPF and why that's interesting, then I'll work on this while you're doing that.
Yeah, I mean, there's a lot to say about eBPF. I think probably the most important thing that I would want to iterate to folks is it's still kind of new and it's still kind of being worked down. But boy, is eBPF the new hotness. Everybody's using it. And really what it does is it's think of it as just an avenue for us to parse information out of the kernel, and we can do arbitrary things with it because it is so flexible and so extensible. So using eBPF, we're able to pull syscall information out of it, but for instance, Celium uses it for networking. They do network packet authentication with eBPF because they're able to basically dive into the kernel and run arbitrary logic. And so they actually attach an ID to every network packet, and they're able to validate that as it comes to wherever it's supposed to be going. So eBPF is a really cool protocol. I'm going to give a big shout out to Lorenzo here. He just joined the chat. He's one of our engineers in Italy. He just wrote a book on BPF, if you want to pull it up. It's coming out for print soon, and we're going to have him doing some book signings over in Europe. I think it's just type eBPF O'Reilly book. Let's see if we can pull it up. I think it's for pre-order right now.
I think this one.
Yeah, and so Jesse did a forward for him, and he's been working hard on this. And he gave me a copy of it to kind of start going over, and I skimmed through it, and there's a ton of great information in here. So if you want to learn more about eBPF, talk to Lorenzo, read his book. This is going to be a new thing that's here to stay, and folks, I know I'm excited about eBPF, and I think y'all should be too.
No, it's killer. I completely agree. And what's interesting is, like, you brought up a very good point. Like, it is interesting that it seems to me as though, or my experience has been that people are like looking at BPF. We call them the superpowers, right? Because it's like the superpowers of Linux kernel. You can do lots of stuff with it. But it seems like, in my take, it's like people are looking at it from two distinct vantage points. One vantage point being like, how can I basically use this as a mechanism to understand things like systrace on steroids?
Yeah.
And the other being, how can I build efficiency in my network path and be able to use the network as an insertion point for like a layer 7 or application level constructs using the same set of tools, right? So BPF and XDP and those things work together to be able to allow you to define networking between pods and networking between nodes in ways that we've never been able to really accomplish. I mean, the closest is like Open vSwitch, but even comparing those two has been like really amazing. You know, like what you can do with BPF is nuts.
And I think it's important to call out that there's a subtle, Diet Coke. A subtle difference between, it wouldn't be TGIK if I wasn't pounding Diet Coke the entire time.
There you go.
Between BPF and eBPF, which that's pretty much like eBPF is to BPF as VEM is to VI.
Yeah.
It stands for Extended Berkeley Packet Filter, and it's just like a more advanced or more modern version of the BPF. I'm going to mess this up if I say it any more times, of the BPF protocol that's been around for a very, very long time, several decades.
All right. So back to this config manager. So this is the daemon set definition here that I'm looking at. And what they do in the example is that actually in the repo is they have a line here that says like these three lines where you set an environment variable, sysdig BPF probe, and then set it to anything, and it will do something. And it will basically use BPF instead of the kernel module.
Yeah, and this is interesting. You actually have to set it to empty string. You don't set it to false or you don't set it to true. You just set it to empty string.
Gotcha. So if I go in and I look at the daemon set that's there, and I look for env, I can see that that's actually not populated.
It's not there because Kubernetes goes through and it alphabetizes everything and gets rid of all your comments.
Yeah. So right now we're running with the kernel module. So what I'm going to do is I'm going to do kubectl delete -f Falco daemon set config map, and then kubectl get pods. We'll see those going away. Now this is kind of interesting because, well, I won't noodle on it, but like what's happening here is that I actually just used a file that gave Kubernetes enough of a coordinate to be able to delete this thing, and now those pods are gone. but the file that I use is not the file that was in place.
I've noticed this behavior as well, and I looked into the code once. All it does is it checks the name and the labels and the name, the labels, the meta information, and what namespace it's in.
And no more than that. Like, it literally just looks at that. It's like your scale event, right? If I do kubekettle scale and then I give it the name of an object, all it cares about is that that object exists. It doesn't care like what version or where it is in its scaling already.
The reason it's like that, though, there's actually a good technical reason for that. Because in Kubernetes, in memory, when you unmarshal the object, you also munch that together with the meta information, like the status and everything, and you'll get a temporary ID. And if you were to actually ever try to redeploy all that information, you would get an error because it's Kubernetes' responsibility to create that, not you.
Unhappiness.
Runtime error, can't open BPF probe. Okay, so we have to load the BPF program. Ooh, we might be hitting a wall here.
Looks like it's trying to download the precompiled BPF from here.
And we're getting a 404? Yeah.
Maybe because the kernel mod, maybe because, well, that's weird. Let's go there.
Yeah, let's jump in the container and let's try to pull the kernel modules and see what happens. I think I opened up an issue on this actually. This is how good my memory is. I can't even remember the GitHub issues I've opened.
So what if I just what if I tried to pull that object myself? It looks like it's just not able to get it. So yeah, sure enough. The thing it's trying to get, the sysdig probe binary for BPF for this kernel module, for this version, is non-existent in your S3 bucket. So I agree that we're probably in a checkmate situation. Anybody got any ideas?
Yeah, let's jump in the container.
Okay. Kubekettle exec ti Falco bill bash.
And I know Duffie, he was on the call earlier, I don't know if he's here right now, he's doing a lot of work. He's been slimming down our Docker images and giving them a once-over, so I am imagining as soon as we release these new Docker images, it'll come preloaded with a working URL to get the eBPF program.
The problem is I can't jump into the container because
it keeps dying.
Crash it back off.
Crash it back off. Okay, somebody in the chat says they keep restarting. Yeah. Okay, so I have an issue on it. It's issue number 769. So I think this is a great place for us to wrap up, and I think it's an excuse for us to do another one in the future.
I agree with that. Even if we don't do Falco, like I think that you and I should just co-host this stuff because like, you're a tremendous investment in keeping in even starting this whole crazy channel. Like I love working with you, and I would love to continue to do that, regardless in whatever form that takes. Like,
yeah, I mean, obviously we want to be good open source citizens on our end, and you know, if we have time, we can definitely make some stuff happen.
Yeah. You want to look at a particular issue?
No, I mean it's issue 769, but it's just exactly what you just ran into. We don't need to pull it up.
Cool.
So yeah, let's
flip back to face here.
Thank everyone for coming. Happy Friday.
Good to see you all. I'm glad you were here. I'm so glad that we were able to like all. And actually, hey, there's my BPF sticker right there. I got that from BPF. I love it. Yeah. Anyway,
so yeah, I mean, and coming in, and like I hate using the phrase like taking over a project or saying like, you know, my project is Falco or whatever. Like I don't really agree with that vernacular. It's everybody's project. But coming in and being someone who has a lot of responsibility for the success of this project, like knowing that there's a lot of work and that we're going to be doing it in open source is really exciting because it's an opportunity for folks to come and get involved and to work on really, really brand new, exciting technology with a really awesome tool that I personally think is going to be pretty successful.
Yeah.
Yeah.
I mean, I agree with that. That resonates with me. Like, in my mind, it's like if the best security tools that I have ever become aware of were open source tools. OpenSSH is an open source tool. You know, Git is an open source tool. I'm not considering these security tools, but they're tools that we use so heavily, and we're able to like, you know, the Linux kernel. All of these things are open source projects, and so like, you know, seeing Sysdig and Falco and those sorts of projects where we're like really upping our game and understanding what's actually happening at a syscall level, like be an open source project is I can't imagine it working any other way. So I'm really excited that you're working on that.
Yeah, thanks. I like to use the analogy, like if we look at encryption algorithms,
Yeah.
the fact that they're open source is that's what makes them so strong. Is we have eyeballs and brilliant engineers from all over the world looking at them and working on them, and we're all benefiting from all of these individual one-off use cases around the world. And I mean, who's going to run an encryption algorithm as a service?
Yep.
It's what you do with it.
Yeah.
Yeah.
All right. Well, cool. Thank you all. Do we have any other questions?
Let's tell bye to everyone. Let's say bye. Thanks for a great TGIK from Sean. Thanks, Adam. Thanks for answering my questions. Rory, cool. Thanks, they were super interesting. Joy, thank you for the session. Vincent, thanks. Lorenzo, good to see you. Good to see you, Lorenzo. Now go enjoy your weekend and stop working.
That's called vault. Very good point. Yes.
Thank you, Kris and Duffie. TGIK. Nice session. This is every time. Thanks, Kris and Duffie. I love what Duffie is saying right now. Wait, what did you say? Oh, that's called Vault?
Open source. Got to be open source or bust. Open source or bust.
+1 to both more Nova and more Duffie. Thanks for the session. Great job. Thank you both for another great TGIK. Thank you all. You're the best. Timmy, it's good to see you. Come join the Falco channel. We'd love to see you there. Even if you're just interested and want to find out more, we're always hanging out there. We'd love to see you. And we'd love to see you on the calls as well.
Thank you all.
Thank you.
Have a kickin' weekend. And next week, it's going to be so much amazingness from VMworld and just generally in the community. So I'm just like, I'm beside myself watching us. You know, you were a part of that. We're a 100-person team at Hekio, and we're turning the boat that is VMware.
Slowly.
So
are you not doing TGIK next week?
I believe that Christian Dickman might do it.
Okay.
And Christian actually recently did a TGIK on it was one of the storage pieces. I can't remember what it was called, but Christian was actually interested in doing it next week. I can't remember what he's going to do it on, but it sounded really exciting. And if that happens, you'll hear more about it early next week in our usual Twitter announcement. But yeah, thank you all. Have an awesome weekend.
Okay. Oh yeah, and Pop brought up sorry to cut you off. Pop brought up a good mention that Sysdig is going to be at VMworld.
Yes.
So go say hi to everyone at Sysdig.
312?
132?
132.
It's in the notes. So
Okay.
just check the notes.
It's in the notes.
Okay. We're really going to leave this time.
This time for sure.
Okay. Bye everyone.
Bye.